going to look at some more topics, if you like, inside 15.1, double integrals over rectangular regions. Hopefully I'll get those done today. I'm sure I will, and we can start 15.2. Yeah. Double integrals, order of integration. If you're given a double integral and it tells you what order to do them in, I would just do it in that order. There's probably a reason for it. You know, so if it says the integral from 0 to 1, 5 to 10, some function dx, dy, do the dx first, right? Because that's what you should, and then do the dy second. There's nothing to do here. But here we have a question where you have control. And there are a number of questions that you could have control. They could have written this like this. That would be the same information. I've seen them write it like a very kind of long-winded way, which is the same thing. Okay, I think that's every possible way you could write those intervals down. Now, the question that you have to choose or have to decide here is, do I do x first or do I do y? And the answer to that question can be, it doesn't matter, in which case it's not a problem, just whatever one you feel like. Or it does matter. And if it does matter for two reasons. One of them is that one order is just a lot easier to do, so that's a good reason to do it. And the other reason why it does matter is that in some situations, you can only do it in one order and not the other. So we've got this guy here, 0 to 1, that's the x's, 0 to pi upon 2. It doesn't matter because I'm going to do both of them, but so it doesn't feel like it's a setup. Tell me, x or y first? I'm going to end up doing it both.
Y first, I think.
Y first. Okay, so it's going to be a double integral of all this. You do y first. That's what I was asked to do, and then you do x. And I'm putting the little labels on, as you can remember yesterday. The one time I didn't do it was the one time I got all screwed up. You can choose to put these limits on or not. You know, I mean the axis and y part at least. Okay, let's integrate this fella with respect to y. So we're going to do an integral from x equals 0 to 1. And with respect to y, x cosine xy, partial integration with respect to y, the cosine becomes a sine xy. So you'll get x sine xy, but don't you also get something else? It's essentially a chain rule in integration. So the antiderivative of x cosine xy isn't just this. What else is missing?
1 over x?
Yeah, if that was 2y, wouldn't you do 1 over 1/2, right? If it was 10y, wouldn't you do 1 over 10, right? So if you do a 1 over x, can I just simplify my line and say that gets cancelled? You could read the x that was there would get cancelled by the 1 over x. This guy here is just a classic polynomial, so I'm not going to lose any sleep over it. Whoops, put in the x first. And we're going to evaluate this at y equals 0 and y equals pi upon 2. This is going to be the integral from 0 to 1 then. It's going to be the sine of x times pi upon 2, which becomes pi upon 2x, plus 1/2 x pi upon 2 to the power of 4. And then you plug in 0. So it's takeaway. The sine of 0 is 0. And if you plug in here, you get 0. So if I know it's a whole load of zeros, why don't I just call it 0? And let's make it a little bit prettier. It's the sine of pi upon 2x plus some really ridiculous guy, but I should be able to do it. 2, 4, 8, 16, 32, 64th, 1/64th pi upon 4. And we're going to do dx. Are you okay with that? We followed it. Great. If I've made the mistake, of course, tell me, but does it look good?
You forgot to x
Nah.
on 1/16.
Yeah, you dropped
The
the
x here. Thank you. Right. We good now? Oh, it's there. I just didn't put it there. Okay. Okay. This is Calc 2. If you're doing a double integral, the second integral will just be Calc 2. So integrate the sine of pi upon 2x. Well, integrate a sine, you get a negative cosine. Won't that pi upon 2 generate technically a 1 over pi upon 2, but isn't that 2 over pi? Okay. And this guy is yet another power rule.
Isn't the
And we're
1/16?
going to value.
Isn't the 1/16 supposed to be 1/64?
Yes, it is.
Okay.
You're right. I'm actually thinking this line, which isn't a good idea for my brain. That's 1/64th. 1/64th gets another 2 added to it, so now it's 128. Okay, plug in 1. Negative 2 over pi cosine pi upon 2 plus 1 over 128 pi upon 4 times 1 squared. That's all that stuff. Take away. You plug in 0 in here, you get the cosine of 0, which is 1. So you actually do get something. You get that. And you plug it in here, you get some zeros. And there's not really much I can do here, except rewrite it again. It looks like we have an answer. Well, good. So that order was successful. Now, it might end up being that that's the only order that works. Or it might be that the other order was a lot easier to do. Right. So let's find out. I'm going to do the integral. I'm going to do y equals 0 to pi upon 2. And then I'm going to do x equals 0 to x equals 1. The same function. That's not going to change. I'm going to do x first and then y second. Okay. Well, let's see what's going to happen in this case. With respect to x, actually, I may not even do this question, but with respect to x, what's that going to be? How am I going to do that integral?
That needs to be integration by parts, I think.
Agreed. So I've changed what I was going to do here. And this fella is doable. This fella is just 1/2 x squared y cubed. And it's going to be evaluated from x equals 0 to x equals 1. Would you agree that integrating x cosine xy generated a relatively nice answer? Whereas if I chose to do it this way, can you see how ugly that is going to become? Or at least how much work is going to be involved in doing it. So in this particular question, doing the y's is less work. If you do the y's first and then the x's, is less work than the x's first and the y. Now I can just leave that for you, and if you want to finish it off, you can, but I can tell you right now, that answer will be the same as this answer, because the order of integration does not affect the result, right? It just affects how you get to that final destination. Are we okay with me just saying, I'm not going to do all that? Because I could do it in 10 minutes. Who wants to use that 10 minutes up? 5 minutes more likely. Are we good? Right. So have I convinced you that if you have a choice, that sometimes one of them is better than the other? And that's kind of what my goal was. So, second thing we're going to look at is actually using a double integral to find the volume of some object in 3D space. So we're going to find the volume. So this is a bit like question 12. And we're going to find the volume of 4x plus 10y take away 2z plus 19 equals 0. And the region on the floor is x between 1 and 4 and y between 1 and -1. In this particular case, I'm going to do the x's here, which means I'm going to do the y's first. So the only guy that's missing is what function goes here to find the volume of what that surface would look like if you projected it down. So maybe I'll try and visualize it. On the floor, from x equals -1, which is about here, to 1, 2, 3, 4, x equals 4 is about here. And from y equals -1 here to y equals 1 here, you have got on the floor that guy, right? He's R. In this case, above the floor is this guy. Do you recognize what that looks like in 3D world?
A plane.
It's a plane, it's like a flat piece of paper, typically at an angle. So can you imagine that I have a plane, yeah, big version of it, going like that. Now, if you imagine each corner going up, they will reach the plane at a different point. I know this is getting really messy. Can you see that funny, it looks like a lean-to shed? That's the volume you're trying to find. See this little blob in here? Where the surface cuts down. Imagine the rectangle going upwards and it getting cut by a diagonal knife. That solid shape is the volume we're after. Okay, back to the question now, which is, I need a function of x and y. That's all I can have. I can't have z's. Here, that represents this fella. So how do you think I might find that guy, even if you can't tell me what that guy is yet?
Well, don't you want to set the equation equal to z because you don't want to have any z in the integral part?
That's pretty much it. That's exactly what you do. So I'll do the kind of working over here, which might be how you would do it. I want to solve for z. So as long as you do it to both sides okay rule, so I'm going to subtract 4x, I'm going to subtract 10y, and I'm going to subtract 19. And I'm going to divide everybody by -2, so I get 2x, I get a plus 5y, and I get a plus 19 halves. That guy is him. So if you're ever trying to find the volume of a shape, it's a double integral of z, whatever you want, dx, dy, dy, dx. That's the generic formula for finding all volumes. So in this case, it came out like that. Do you know sometimes It might be that guy, right? In which case, and the reason we typically take the positive square root is, don't we normally have the floor and it's a bit above the shape that we're interested in? So that would have been the ugly Z that would have fitted in here. And wouldn't want to do that one. So are we comfortable with how to set up, find the volume of a shape? You'll be given a function. You'll rearrange it to be Z equals, it goes here. You'll be given the range of values for X and Y in various formats. Just looking at that guy, would you agree it really doesn't matter if I do X's first or Y's first? Typically, if the function is a polynomial, you know, X's, X squares, whatever, it's not going to matter. So it's going to be the integral from -1 to 4 of, with respect to Y. So I almost made a mistake there. What is the antiderivative of 2x, or the integral if you want to use that word, with respect to Y?
2xy.
Great. Do you know what my mistake was going to be? Any guesses of what kind of mistake I could have made?
You were gonna drop it?
I was going to drop it, which is what I would have done if I was differentiating. Sometimes you forget which hat you've got on. Now this fella here is a power rule. And won't this fella here have a y attached to it? So it's going to be the integral from 1 to 4. Let's see what you get. If you plug in 1, you get 2 times x plus 5 upon 2 plus 19 halves. Take away. If you replace y with -1, you get a -2x plus 5, 2, and then -19 over 2. Let's see what that gets me. I get a 2, take away a -2 adds it, so I get 4x. I have a 5, 2, take away a 5, 2, that's interesting. 5, 2, take away, yep, they cancel out. And I have 19 halves, take away a 19 halves, which means I add it, which means I get 38 halves, which means I get 19. And now it's a Calc 2 question. So power rule, add on an x. If you plug in a 4 here, you get 32. If you plug in a 4 here, you get 38. Take away. If you plug in a -1 here, you get 2. If you plug in a -1 here, you get negative thingy halves.
Wait,
yes.
Why would it be 19 halves? Because isn't it 4x plus 19?
Oh, good. Yeah. Yeah. I don't know. Just felt like it. 40, 76. It's actually going to make this a little bit nicer. What's that? 98. What's that? Take away basically -17. 115. Or thereabouts. So I'm glad you're paying attention. My brain's somewhere else today. Probably will be for the next week. Got some things going on. So we have this. So if you have to find a volume, and there's what I think 2, maybe 3, but definitely 2 questions in the homework like it. Rearrange this so it's a z equals, that goes there, and then your limits of integration, and then do your thing. We okay with that? It's a process, right? Last one, yes.
Back on it, shouldn't be 2 plus 19.
This one here.
Yeah, isn't that 2
Um,
plus 19?
Well, if you want to do that, you could say it's -2 plus 19, but the net effect is still to add 17, so it's the same result.
The limit of integration is x equals 4 and x equals -1, so minus 19 is, it works out.
It works out the same.
Okay, I see you now.
I could have called that -2 add 19, but I'd still end up with 115. So average value of a function. A lot of textbooks, this one in particular, always looks to me like you're trying to say fave. I've got a favorite, fave, but it's actually the average value of a function. And its formula is 1 over the area of the region R. You know, the region R is x equals 0 to 2, y equals 0 to 4, right? So it's the area of that, the double integral of whatever your function is, dx. Gesundheit.
Listen.
So I get 2 stories because I get distracted, so I get the ideas out of my head. Do you know when you sneeze and people say bless you or Gesundheit, which is just bless you in German, I believe? Why they say that? There are 2 distinct stories I've heard for why people say bless you when you sneeze. Anybody know either of them?
Didn't people
Oh, you're
used
going
to
to learn
think?
something.
Didn't people used
You
to
go
think
on.
your heart stopped?
Well, I don't know that one, but that could be true as well. The 2 that I know of, the first one is, yeah.
Oh, sorry.
Chris?
It was if you're sneezing, you were sick, and since there was lack of healthcare, it was like, oh, God bless you, you're about to die.
That's very close to one of mine. Both my stories are much older than probably that. The first one is connected to health. Allegedly, one of the first signs of the Black Plague, so that's how long ago this originated, was sneezing. And so when you're at the early stages of the Black Death, right, the Black Plague, you would sneeze. So people would be saying, just like you said, oh God, you're going to die, bless you, right? You're at the beginning stages. And the second one is that it was believed that when you sneezed, your soul would jump out of your body for a few seconds. And so you would bless their soul by saying, bless you, so the devil couldn't get a hold of it for that like second that your body did that. So now you know 2 very old explanations for that. Doesn't help us with what we're about to do, but you know me. Okay, I want to find the average value of a function. You might think, well, what is the average value of a function? Well, can you remember a way back in the day when you did Calc 2? What you did when you found the average value of the function was, if you can imagine every single value of x had a different height, right? Then the average value of the function would be the average height. So if this represented temperature over, a 24-hour period, the average height would be the average temperature during that period. So if you do a 3D surface, so if you imagine you've got your 3D surface, right, that guy. In this interval or area, there are various values of z. What you are finding is the average height of that function for variables that are in that region. So it's like the average height of the shape in that rectangle. So let's do an example. They're actually very easy to do, and the information sometimes given a bit wonky, but you can live with that. So let's suppose I give you a function, and it's 2xy squared, and we'll tell you what the region is in terms of this notation. Looks like that. First thing you find is the area of region R. Well, it's 2 by 1. You see, I didn't even think about it. Can you imagine the x's go 2 units and the y's go 1 unit? So 2 times 1 is the area of the rectangle, the area of R. Are we okay with that? Just virtually doing it in my head. Now, the average value of the function then is 1 over 2. The integral from 0 to 2, the integral from 0 to 1. That means I'm doing the y first and the x second. And the function I'm going to do it to is that one. So whatever this comes to will be the average height of this function here in that rectangular region of space. So it's going to be 1/2 the integral from 0 to 2. If you integrate this with respect to y, you get 2/3 x y cubed. If you plug in 1, you get 2/3 x. And if you plug in 0, you get nothing. So it's 2/3 x take away 0, so I'll just leave it as 2/3 x. Power rule on this guy. Evaluated at 0 and at 2. Plug in 2, you get 4/3. Plug in 0, you get 0, so just leave it as 4/3. And there is the average height of that function, 2xy squared, in the region 0 to 2, 0 to 1. Are we okay with how to calculate the average value of a function? Is there anything about that
I
that
did
you're
not
sure about?
understand from where you went from
Mhm.
2/3 xy cubed down to 2/3 x dx.
Okay, let me show you what that looks like. So I had 2/3 xy cubed being evaluated at 1 and at 0. So I'm going to replace y with 1. So it's going to be 2/3 x times 1 cubed. Subtract, I'm going to plug in 0 now. 2/3 x times 0 cubed. 1 cubed is 1. 2/3 x times 1 gets you 2/3 x. Nothing cubed is nothing. Nothing times this is nothing. So that's where it came from.
That makes sense.
Okay. Always a good idea to tell me, because I guarantee that you're not the only person. Are we cool with that? There's only one average value function. Homework question. But basically, that's a template for every single one in the universe. Right? It's 1 over the area of the rectangle. In this case, it's a rectangle at least. And then just find the integral as usual with the limits that you're given. Any questions about double integrals before we now move on to double integrals over non-rectangular regions? We good? Okay. I feel like I'm at a wedding ceremony where I should be saying, do you know what's that phrase? Or forever hold your peace. Does anyone here?
Can you show the bottom of that answer real fast? The one that we just did for the final answer.
Yes, I'll have it on the screen shortly. I'm just moving on to, if I can. Okay, what window am I
Thank
on
you.
now? I have no idea what window I'm on. Oh, can you see it? Can you see the white paper right now?
It's visible.
No. Is it? I'm not quite sure what you see. Right now I'm trying to get into Cengage because I need to move to the next section. And I think it timed me out, or at least it kicked me out. And now I'm trying to find the damn thing. So, and here we go. I got it.
Professor,
Yes.
would you ever find like improper integrals in more than 2 dimensions?
Oh, you know, like a 0 to infinity thing?
Yes.
Maybe the x's go from 0 to infinity. Technically, yes. Do we ask you to do it? No. And you would actually do it the same way that you would have approached it in Calc 2. So I wouldn't even take notes on this in case you think you're going to get a question on it, but just show you what it might look like. You know, there would be an improper one. Do you see the infinity here? What you would do is you do this guy the usual way, right? And then you would do the limit as t tends to infinity from 1 to t, whatever that became, dy. So it would just turn into a Calc 2 question. But if ever there was a 1 to infinity, like if one of the limits of integration had an infinity in it, it would be a good idea to make sure it's the last thing that you do. You could theoretically, again, I wouldn't write this down. If the variables are separable, you could even do a double infinity. Now, what are the answers going to look like? Well, you could get the answer that the integral diverges. In other words, it's got an infinite volume. Or you could have it converges. But in this case, both would have to converge for it to be true. So, yeah, you could get it. Do you ever get them? Nope. There aren't any homework questions in it. There isn't a section where we do those. But theoretically, yes. Are we cool?
Thank you.
You're welcome. Now, we're now about to start the intro, because I'm not going to do the direct double integrals yet, to section 15 too. And it's still double integrals. But it's going to be over non-rectangular regions. So can you imagine that we're going to integrate, right? We're going to do this shape on the bottom going upwards, but the shape in the bottom will not be a rectangle. It will be typically things like this. Can you imagine a triangle on the bottom? And you go up and you meet up with the shape. And if you did that, God, I wish I was a good artist. Can you imagine it look like a Toblerone bar, but not flat at the top, but curved at the top? And a double integral would be calculating the volume of that shape, for instance. So the types of shapes that you're going to typically deal with are triangles, parts of circles. But mostly triangles. So far, so good. So before we even get into the questions of how do you do double integrals when the region they are, we'll still call that R for region, right? Where R is not a triangle. So I need to set up a skill thing. So I'll show you what we're getting at. Imagine that the triangle on the floor was this shape here. And it goes from 0 to 3. And this fella here, the straight line, is y equals 3 minus x. We need to find a way of creating the region R for this triangle. And there are two versions of it. And the reason we need two versions is the same reason we needed it earlier today. Can you imagine that sometimes doing the x's before the y's is less work, or is actually the only one that's doable? But sometimes it's the y before the x's. And so we have to figure a way of describing this region in two distinctly different ways. For visual people, I'm going to describe it vertically, and then I'm going to describe it horizontally. And each one is equivalent. In other words, if I used one or the other, I would still get the same double integral answer if it was one of those questions where you could do it both ways. So it doesn't change the answer, it just changes our approach to how we're going to set up the double integral and how we're going to do the algebra that results in that. So here is the vertical way. Imagine a random vertical rectangle. And this rectangle is going to be at position X, right? Because it's on the X-axis, right? In this rectangular world, if you wanted to make this shape happen, can you imagine the rectangle would go here and it would scan to here? The X's would go from 0 to 3. So I now have my X's. Now, what would the Y value do for a typical rectangle? Well, wouldn't the Y value in this case start at 0 and it would finish here? Right? But, oops, start at 0 and finish here. Here is in terms of X's. So the Y would start at 0 and finish at 3 minus X. So for any given rectangle, the Y would start at 0, but its height would be whatever 3 minus X height was. We've now created this region R. Its X's go from 0 to 3, and the Y's go from 0 to 3 minus X. You follow that?
Is this the horizontal or vertical one?
This here is the verticals. My rectangles are vertical. Let's do the horizontal now then. I think I'm going to draw my triangle again. And I'm going to go horizontal because my rectangles are horizontal. Now, if you wanted to create this shape, wouldn't these guys start at a y0 and finish at a y of 3? Okay, y0, that's its position. y3. That tells me now, what would the x's do? Oh, by the way, this line is called y equals 3 minus x. But with a little bit of rearranging, would you agree that it's also the line x equals 3 minus y? I wish I'd put a 2x or a 3y in this to make it a little bit different when you see it both ways around, but too late now. You're comfortable about this as the same thing as that. Now, why is that important? When you do this version, isn't the, right, when you look at what particular guy I'm going to go, aren't the x's going to go from 0 to here? And the x's are going to go from 0 to 3 minus y. So if you have this region, you could describe it using this combination of x's and y's or this equivalent combination of x's and y's. Are we good? Any questions about that? Okay. Let's do a quadratic. It's going to be my region R, right? Yeah, I'm going to do a vertical version, my vertical rectangle. Okay. This vertical rectangle, if you wanted to create this shape, wouldn't you start at x equals 0 and you do lots and lots and lots of vertical rectangles and you'd finish at 2. So you'd have an x equals 0 to 2. For this vertical rectangle, what is the y coordinate of the bottom and what would the y coordinate of the top be? Well, on the bottom, it's 0. Getting all sorts of colours here. What would the top be?
Just x squared, right?
Yes. So we've now described that region using vertical rectangles. Are we good? Right, now I'm going to come back to that question, but not yet. Suppose the region that we're interested in is this half circle. And I'm just randomly choosing my vertical rectangle again. This particular fella happens to be x squared plus y squared equals 9. At least that's the information that you're given, but it probably won't be the information I'm going to use. We're going to try and create what that region would look like. Now, if you're doing vertical rectangles, If you wanted this shape to happen, wouldn't you start at x is -3, and then you just do lots and lots and lots, and you'd finish at x equals 3. So that would give me those guys. Now y is 0, right? Starts here. And the top of that rectangle. Well, I know the curve is called x squared plus y squared equals 9, but I want to know what that looks like in terms of y. Now, normally when you do a square root to both sides, you do a plus minus. But in this case, would you agree it's the top half of the circle, so I know it's a positive square root. That is this curve. So the y goes from 0 to here. The y goes from 0 to here. Do you notice that, at least in these questions, isn't one of the pair a start value of x and a finish value of x, both numbers? And the second one is a start value of y and a finish value of y. And at least one of these, typically the second one, won't the second one be in terms of the equation of the curve using x's? At least in the version. Now, if you go horizontal, it's almost the same thing, but won't you have the equation of the curve given in terms of y's?
Shouldn't be one of the ranges for x be -3 to +3, not -3 and -3?
Did you all catch that deliberate mistake? Yes, it should be. Now, I said I'd come back to that one. Let's come back to it. Now, the reason I'm spending all this time just building up skill set of how do you describe a non-rectangular region in terms of x's and y's is because that's pretty much going to be step one in many of the later questions. So let's go horizontal on that. Now, this is not as obvious as you think. Firstly, are you all happy about why I know the y coordinate of this point is 4? Right, x equals 2, the height is 4, right? Just in case you're wondering. Now, let's see, and this one is going to be messy. But I could imagine a situation where it might actually be the order that you want to do it in. Now, if you imagine these rectangles, won't the y start at 0 and it would finish at 4, which is why I needed to find out where that 4 was. Now, this curve is called y equals x squared, but if I rearrange it, isn't it also x equals the square root of y? Great. Now, be careful here. We want to know where this rectangle starts and finishes. And we want to know where it starts and finishes in terms of numbers or y's. Where does this curve start? And that's what I should write here. That's the start. No, it isn't. If it started at 0, it would be where my finger is.
That would be 2 minus square root of y, I believe.
You've got, oh, you're talking about, sounds like you're telling me the whole thing. Where would that be? Just that. That would be the square root of y. Where would that be? 2. So if that's what you were saying, then I agree with you, G.
No, I was saying something.
This rectangle starts at 2, right? It starts at an x equals 2, and it finishes at this point here. Now, how do I know that that's that guy? Isn't the equation of this curve x equals the square root of y? So won't the x coordinate at that point be the square root of y? Either one of these regions would work equally well in a double integral question over R. I can imagine that one of these two might be easier math than the other. And it might be even the only one that's possible. So if you're doing a double integral, even if it's a rectangular one, and the order x is first and y second, just doesn't work, right? You can look at it and you're going to say, oh God, that's going to take me forever. Or I don't even know how to integrate that. Then that's probably a sign you should switch the order. So if you're doing a double integral over a non-rectangular region, and that's the one that you're using, and that one doesn't seem to be working out well for you, right? That it doesn't look good. You know, it looks, oh God, that integral's murder. You may want to think about the second choice. Now, in the vast majority of situations, both of them are equally correct. They both work, and they both probably involve about the same amount of work. So to heck with it, it doesn't matter. But for those questions where it does matter, right, it's important that you have the ability to switch. Are we cool with it? So let me show you. Let me not show you anything. Good grief. It is time. I apologize. I didn't realize that I was having so much fun. We'll talk about it tomorrow. We'll actually start doing double integrals over non-rectangular. And would you like to say hi for attendance? And bye-bye. And I know some of you have some issues, so you want to just hang on and we'll go over those homework questions, test questions, whatever it is you want. So, but for the rest of you, goodbye for the time being, and I'll see you tomorrow. That is cool stuff we did today, Anna. That was fun stuff. You have, okay, who's going to go first? Last time I can't remember who it was, and then my wife told me our dog is still with us, which I'm glad to say. She had to, we thought she was going to get a colonoscopy, but they did a hand examination, and she got a sonar scan instead. And so we already knew she has a colon growth. So they did a biopsy and they're looking to see if it's cancer. So that's where we are. So if you're wondering why I'm making even more mistakes than usual, half my brain is thinking about my dog. So I'm even more careless than I normally are. Right, what you got? Who's first?
So I was just asking about one of the questions from the test that we just did.
Go for it. Is it something I can write down quickly, or will I have to go looking for it?
I have it right here.
Can you just read it out loud? Okay,
yeah.
Read it out to me and I'll write it down.
F of xy is equal to x to the fourth plus y to the fourth minus 4xy plus 3. And that is from,
and it's just,
s is less than equal to 0 and less than equal to 3. Sorry. And y is between 0 and 2, inclusive.
Okay, I'll put that on the screen and you tell me if that agrees with what you are saying. That's it?
Yeah, for xy plus 3, 0, 3, 0, 2. Yep.
Okay,
That's
so
what, then,
this is going to be find the absolute max and min, I'm assuming?
Yeah, find the max and the min. Yeah. So I was able to find the mean. Yeah, I was able to find the mean for the problem, but I wasn't able to find the mass. The max.
A maximum.
Yeah, I was not able to find a maximum.
Right.
Yeah.
So can I assume that the one that you found was that you solved that?
That's correct. I did solve that.
And that came up with a maximum, right?
That gave me a minimum, actually.
Oh, a minimum.
That
okay.
gave me a minimum.
So it gave you a minimum.
Yeah.
And the point that it gave you has to be in that restriction. So was it 0, 0 or 1, 1 or whatever it was?
It was 0, 0, 1, 1, and -1, -1.
So you had 0, 0, 1, 1.
-1.
Minus 1, 1.
-1, yes.
Minus.
And
Minus 1. And each of them, did they give you the same value, or one of them was smaller than the other two?
so the 0, 0 was a saddle point. And then the last two were the local mean, were the same value.
So they're the same point,
Yeah, same
right?
point, yeah.
Okay. And now we're going hunting for maximums, right?
Exactly. So that's where I was a little bit confused.
This is where this is going to come in.
Okay.
This is the region that they're talking about.
Okay.
This region here. So what I'm going to do is I am going to look at technically what is happening on the boundaries.
Okay.
And then I'm going to see, is there any place on that boundary that you would hit a maximum? In other words, a number that is bigger than whatever that guy is. Right.
Okay.
What guy was your minimum anyway? What number was your minimum?
Minimum, I had one.
I had one, right? So
Yeah.
now, technically speaking, you should just check the boundaries, but in fact, there's a shortcut. All you need to do is check the corners. So check 0, 0, 0, 2, 3, 0, and 3, 2. And one of those guys will give you a value to the function that's bigger than 1, and that's the maximum that you're looking for. The reason you couldn't find it with this fella was because this fella only talks about the entire world.
Yeah, that's right.
It doesn't take into account, and you can't really do Laplaces on these because there isn't a optimization function, you know, x squared plus y squared less than or equal to 3 kind of thing, right? It doesn't have that shape to it. So the way you get around it is you basically just check. Technically, I'm actually checking the lines, but really the shortcut is you only need to check the corners. So one of those four guys, maybe there's a draw, will be bigger than 1, and that's the max that you couldn't find.
Okay, I only did 3, 2, but I didn't do the other one. I didn't do 0, 2, and 3, 0. I didn't do those ones. I only did 3, 2.
Well, that's Murphy's law, which is the ones that you didn't check are the ones that you should have checked, right? So if you've checked that one, it didn't work. My guess is it's that one, because this one has already been checked earlier on, right?
That's right.
This is 0, 0. So you only have 2 more points to check then. So we'll cross that one off your list, and you've done that one. I could probably guess that right now. What would 3, 0 get me? 3, 0 would win. 3, 0 would be a bigger number because it would be 81. No, it wouldn't be 84.
So that's what it was.
And 0, 2 wouldn't be quite as good. 0, 2 would only be 2, 4, 8, 16. That would only be 19. And that one wins.
Okay, that's the reason why. Okay, all right. Now that makes